Alright, so in most programming language there is, I assume actually all of them, there is a data structure called a queue. A queue is essentially well, for lack of a better term, a list of information where you stack blocks of information. Well, it's not a stack, it's complete opposite, but imagine you have an output and an input into your big black box of data structure. When you input a something into your queue, so let's say your queue would be a queue of positions, right? So you want to input queues, it would go at the front of your queue, right? So that becomes, let's say, the position 0, 0. And then you can have another position coming in later. That could be any position, really, the position of your player. And then you get another thing going in, inputting. Wait, can you see my mouse? I don't think you can see my mouse. So you can get another thing inputting over here. It keeps piling up, essentially. And once you ask, so that's I'm looking for the, okay, so the name of the instruction. Most of the time the instruction is going to be called push. So you push a position, and then there's something called a pop. Once you call push, that's what we've been doing. So you add an instruction inside your queue. When you pop the queue, pop will remove this instruction over here. Remove this instruction over here, and we'll give it to you. We return this instruction, and then everything in the queue moves up the queue, right? So it goes down in it. So the only thing you have to worry about the queue is essentially which item is going to place it first, because they're also the first item that are going to get out. So it's something called first in, first out, or FIFO. So first in, first out. And essentially what I was talking about when it comes to your player position, you have your let me make sure of the color. You have a red square. No, red square is the enemy. You have a teal square. And let me make it an actual square. So you have a teal square that's moving around and has a trajectory, right? And over time this position changes. I assume you're already keeping the position of this this square in check to place your purple circle, right? Well, essentially not each frame, but close to each update, you could also keep track of the would-be position of a purple square, right? But just not show it. And the way you can do this using a queue is that you enter the player positions at any given time. So this would be the first instruction that got in, and this would be the second, and then you get the third, and then you get the fourth, and you continue stacking them up. That's what you put in a queue. And then once you pop it, you have a perfectly good position that you can then use as the render position of your purple square. So the first pop would be at the original position, and then the second pop would be here, and the third pop would be here, and the fourth pop would be here. So by keeping this queue, essentially you're keeping a place in time suspended. And well, really there's nothing right now that is keeping your queue from piling up to eternity. So my first thought when seeing this problem is keeping a size for your queue, right? So you have the zeroth instruction or the first instruction. You can't actually access them normally in a queue. You can just only do push and pop. But just for the sake of argument, you have your queue building up. And then each time you add something to the queue, you can also check for the size of the queue, right? So let's say we have 10 elements in your queue. When you push something in your queue, so you push a position in your queue, you also check if the queue, whatever language you're using, size is greater than, let's say, 10. This would mean you've overflowed your queue. Then you can pop. You can pop your queue, and this will give you the latest instruction. Well, the first instruction that was entered into it. So by using this little piece of code, which is actually pretty simple, you could just do a return over here. Oh, that is a queue.pop. Else you could just return whatever, just null or whatever you feel comfortable with. Maybe just even return like a position that is even outside the playing area, so you don't have to render your square, but you don't have to worry about a null position. Just put it outside. So you can just keep the queue pop position as your future square position. I hope I'm being clear enough with this, but yes. So my first thought when seeing your approach is not a critique of it. Actually, I like what you're doing. I'm saying that if you want a better player feedback, a really easy way to do it, to have continuous movement, is using this very simple. That's not what I'm saying. But this is a very simple data structure. It's one of the many ways to do it. So essentially, if we follow this thing over here, so this could be a add instruction function, right? And you, well, not instruction. I'm kind of making it more complicated than it is, but add position. Or get, it could easily be get next position for purple, and then you push it the current position. Then this piece of code will do just fine. It will return something out of bounds most of the time, but then eventually it will start outputting real-time information as to your last purple square, well, where your purple square should be. So let's say you have the position in time of 0, 0, and then you're going, let's say, in the x direction, right? So you have 0, 1, and you have 0, 2, 0, 3, etc. That's your queue filling up. That's your pushes happening, and right now you're always returning outside of bound or whatever you want it. And after a set amount of time, when your queue gets at like 10 space, you're going to start outputting those. The return's going to start outputting the correct positions that you want, and your square is going to show up at the place you want. That's pretty much the thing I was trying to do in a few words that I can do in a video that I hope is more informative.